A BOD test is run. The initial DO is 12 milligrams per liter. After 5 days, the dissolved oxygen is 4 milligrams per liter. After a long period of time, the DO is 2 milligrams per liter and no longer seems to be decreasing. What is BOD5, BODU, BOD of 5, and KBOD? All right. First things first, let's deal with BOD5. So we know that BOD5, BOD sub 5 is equal to the initial dissolved oxygen minus the dissolved oxygen at day 5. Let's take a look at our picture. So we're dealing with this quantity right here. Okay, so when we have that, we know the initial dissolved oxygen is 12 milligrams per liter. After 5 days, we have 4 milligrams per liter. So therefore, BOD sub 5 is just equal to 8 milligrams per liter. Okay, step 1 done. All right, now in order to do BOD ultimate, BODU, we need to know what DO ultimate is. Okay, so here's the quantity we're looking for now. We know that BODU is going to be equal to the initial dissolved oxygen minus the steady state dissolved oxygen, or DOU, or DO ultimate. Okay, and we're told in the problem that after a long period of time, the DO is 2 milligrams per liter and no longer seems to be decreasing. So that means we're at this part of the curve after some long time and nothing's really changing anymore. So that tells us that DOU is this quantity 2 milligrams per liter. So then BODU is the initial 12 milligrams per liter minus the ultimate 2 milligrams per liter, and therefore BOD ultimate is 10 milligrams per liter. Okay, so let's just keep track of this. BOD5 sub 5 is 8 milligrams per liter. BOD ultimate is 10 milligrams per liter. Now let's erase some stuff to make room for the rest of the problem. Okay, so now we're on BOD of 5, and remember, this is what we already solved for, BOD sub 5. The BOD of 5 is the remaining BOD left in the sample at 5 days. Okay, so if we look at the relationship between BOD5, BOD sub 5, BOD of 5, and BODU, we know that BODU is equal to BOD sub 5 plus BOD of 5. So this implies that BOD of 5 is equal to our ultimate BOD minus BOD sub 5, which is exactly equal to 10 milligrams per liter minus 8 milligrams per liter. So therefore, BOD of 5 is equal to 2 milligrams per liter. Okay, I'll put that over here. And then I'll erase this. Okay, the last step, now we need to estimate this reaction rate constant KBOD. Okay, so let's think about what we know. We know BOD at time t equals 5. This is the remainder of BOD left in the sample. We know how much of the sample has been used up at BOD 5, or at that same time, and we know the ultimate BOD. Now recall, our expression for BOD of time is just equal to our ultimate BOD times e to the minus, did not mean to do that, k BOD of t. Now let's think about what we know. We know this is a constant, and we know this at a very particular time, right? So we know that BOD at time t equals 5 days is equal to BODU times e to the minus k BOD at time t equals 5 days. Okay, this is known, 2 milligrams per liter. This is known, 10 milligrams per liter. 5 is just 5, and so we can rearrange this to solve for KBOD. So let's see, how do I want to do this? Let's do natural log B of D of 5 over B of DU. That's going to be equal to minus KBOD times 5. So therefore, KBOD is equal to minus natural log B of D5 over B of DU divided by 5. Okay, this is BOD5 is exactly equal to 2 milligrams. BOD ultimate is 10 milligrams. And if we plug that in, we should get KBOD is approximately equal to 0.321 over days. All right, so this gives us like the reaction rate of all the things that consume oxygen in the water sample. So that could be microorganisms, it could just be the decomposition of organic matter, what have you. It has this net reaction rate of 0.321 over days. So this is like the reaction rate at which we're losing dissolved oxygen in the water sample.